Now, let's actually look at some exponential growth models and decay. So let's do estimates of the world population. Now, this is in millions. From 1995 to 2003 are shown in this table right here. Notice that's like 5.6 billion, 5.7 billion. It's just written in 1,000, but that's actually millions. 6,002 million, which is like 6.2 billion, 6.002 billion be the best way to look at it. And here's a formula for this particular thing. This particular formula is modeled this way. Notice there's my A term, the 5,344, E, and there is times. And T in this case would be times or the X, but I'm only looking at it from 5 to 10 to 13 years out. Notice 1995 is my 5, so that means this model is probably accurate somewhat from like 1990, but it only works from like years 5 to 13 is about the growth of this right here. So notice if you actually put the number 5 into your T here, notice the population was 5685 and we got 5696. The actual population was 5764. The model says it should be this. Notice we're 1 off here. We're 5 off here. Here we're off 9. 1999 we're off about 9. And here we're off 9. Here we're a difference of 6. Here we're a difference of 1. And here a difference of 5. So this model is fairly accurate as far as putting something that's very close to what the world's population was doing for those particular years. Remember, this is the actual population, and this is what the model predicted it would be using this formula, so it's very, very close. All right? The model's not always going to be exact, but it's going to be very, very close. I mean, it's not like a whole lot of difference. So, here's our question. When will the world population reach 6.8 billion? Well, if it's 6.8 billion, that means we're looking for 6,800 for an answer and solve for T. So what we're going to do is go back to the problem. Here is the basic information a little bit. And I'm going to replace the 6,800 with the P and my T if I want to find the T. Well, how do I actually work this problem? Well, first thing I might do is look at that 6,800 is divide each side by what? 6,800. And if I do that, no, I'm going to divide it by 5,344. I'm going to take this 5,344 and divide it into this. That's where I get the 1.27 like that. Now, how do I get rid of this E like that to get that number right there? Remember, well, what's the natural log of E is going to be that answer right there. The natural log of E will be my answer. So if I do natural log here, I got to do natural log over here. It goes back to what we did in our last homework. The way to get the E, put it in the log. So now I can simply do this. The natural log of that number is 0.24095 equals that. Take and get the T, divide by 0.012744 each side. And it should take 18.9 years. Now remember we started in 1990. So if I add 18.9 to 1990, it will happen very close to 2009. It happens in 2008, but very, very close to 2009 because 18.9 is almost 19. So that's when the world's population should have reached 6.8 billion. I know we just passed 7 billion here rather recently.